Hello everyone. I'm delighted to be speaking to you today. I'm Clive Roberts from the University of Birmingham, and I'm going to be talking about the work we do at the University of Birmingham, but specifically the work we do with an organisation called Rail Alliance, that's part of the University of Birmingham, that focuses on rapid innovation, helping particularly small companies enter into the rail industry, or if they're already working in the rail industry, supporting them with their innovation projects and activities. I have many roles. I lead the School of Engineering here at the University of Birmingham. I'm also the director of the Birmingham Centre for Railway Research and Education. Our activity at the University of Birmingham focused on rail. There's over 180 people in my group working on rail. Across the UK, we have something called the UK Rail Research and Innovation Network, which is a collaboration of universities and companies, which has been supported heavily by the UK government, and I lead that activity as well. I've been working in this area for 25 years. I obviously work in the UK, and as you'll see through the introductory sections, we work in this area both in the UK but internationally as well. So, for example, I'm an advisor to Singapore Metro. I also work closely with Guangzhou Metro, working in India, various places around the world. So let me start by saying a little bit about the university, then we'll talk about the Railway Group, and then we'll talk about Rail Alliance, and then we'll talk about the activities we actually do. So you may have heard of the university. It's one of the top 100 universities in the world, top 20 in the UK. It's a large university that focuses particularly on engineering and employability of our 34,000 students. We have a lush green campus here on the outskirts of Birmingham. It's a place to visit if you're ever here. Within the University of Birmingham, we have a School of Engineering, and I lead that School of Engineering that focuses on electrical, electronic engineering, mechanical engineering, and civil engineering. And across that School of Engineering, we do work in railways, and it's one of the strongest groups here at our university. So the group has been working for 50 years now. It's around 180 researchers. Specifically in railways, we have around 500 students undertaking programs with us around the world. Our group was recognised by the Queen in 2017, quite an honour for us here in Birmingham. And as I say, we lead UKRRIN, the UK Rail Research and Innovation Network, and as part of that, have the physical centre of excellence in digital systems for UKRRIN here on campus. And we have many partners, but the partners supporting our UKRRIN activities are listed here. So companies like Siemens, Bombardier, should be Alstom now, SMRT, which is Singapore Metro, Unipart, Hitachi, Thales. You can read the list. As I said earlier, we work significantly internationally and have a number of really deep partnerships internationally. Strong relationships in China, working with the metros and railways there, as well as some of the universities. In Japan, I have two members of staff from Central Japan Railways seconded into my group at the moment here in Birmingham. We're doing lots of work in India. I was talking yesterday to the Board of Indian Railways. I'm working in Dubai, many places around the world. So just to try and recap a little bit on how and where we do things. So we obviously at the University of Birmingham focused on a broad range of activities around rail, all the things you'd expect a university to do. But on top of that, working within UKRRIN with those big industrial companies to try and accelerate research and development with companies like Siemens. Then we use Rail Alliance to bring together the SME community mainly. So we have 830 Rail Alliance members, as I say, mainly small companies, and we work with them in a networking type activity where they might join together or they might join together with us in order to bid for bigger projects, in order to support R&D, in order to transform their business. And then from earlier this year, we also took on what's called the National College for Advanced Transportation Infrastructure. This is a college which has a capacity for 2,000 students and is focused mainly actually at the moment on rail and supporting the high-speed rail project here in the UK. So that is vocational training. So from school leavers up to advanced technicians. So pre-university type education. focused specifically on rail. And there is some international offering through that. And since we've taken that over in April this year, the plan is for us to grow that international offering under that banner. So a little bit more about Rail Alliance. So Rail Alliance is the UK's, it's the largest cluster of rail companies with 825 organisations, and as I said, predominantly SMEs. It's part of the University of Birmingham, part of the Birmingham Centre for Railway Research and Education, and is delivering innovation and enterprise support to these companies to help them get into the rail industry or keep them innovating and working in the railway industry. We keep a whole set of activities within the Rail Alliance community to keep the network together. So a number of events, frequent newsletters, all sorts of different engagement. And we're part of other clusters, particularly in Europe, so there can be interaction between companies in the UK and, for example, other parts of Europe. So that European Rail Cluster Initiative allows us to interact with a much broader set of groups. So we have many thousands of small rail companies that can come together in that network. So this is the Euro Clusters Initiative. And there's a number of projects, so Project Paris, S-Access, STARS, which are all about engagement with SMEs across Europe working together. And then more locally in the UK, we run a program particularly called DigiRail. We obviously support SMEs in all sorts of ways, but we have particular mechanisms for funding to support with digitalisation of SMEs and digital technologies being brought to market. So this is a picture of our UK Rail Research and Innovation Network Centre at the University of Birmingham, a 3,000 square metre centre for railway research, the hub for UKRRIN in the UK. This was opened actually only just 2 days ago by the HS2 minister, so the member of parliament responsible for the high-speed line in the UK. So under the areas expertise we particularly have, we cover all areas of railways, but there's 6 areas we particularly sort of are world leading in. One is around future railway operations and control, one around data integration and cybersecurity, smart monitoring and autonomous systems, decarbonisation of railways, introducing innovation, and railway education and skills. And I'm just going to talk through a couple of these to give you an idea of the kind of things we do. So in this area of future railway operations and control, we do a lot of work on assessing the benefits of upgrading to new train control systems, so ETCS, CBTC, so new signalling systems in particular, but also how we might change timetables, also how we might change upgrade infrastructure, for example, increasing speed limits, changing vehicles, and the benefit that might give to the railways. So at the heart of this work, we do all sorts of work in this area, but the heart of this work is a simulator, a microscopic simulator that is able to model the operation of the railways. And we use that for various projects. So this example is for the East Coast Main Line in the UK. So this is about 300 kilometre section of railway. And what you'll see is we're modelling right down to, in this case, the old signalling system. So down to the track circuits, points, signals, and the route settings, and all of those white things you can see moving across the screen on the left are trains moving in that network. And we're simulating this, in this particular example, at about 500 times real speed. So we can simulate days of traffic on the railway very quickly. And then what we could do is we could change parts of this, the signalling layout, the route settings, the types of trains, and we can analyse the difference between those sorts of running. So in a planning upgrade sense, we can understand where the benefits might come. And just to show you some different examples, this example is now from, where are we, Singapore. And this is working with Singapore on their CBTC upgrade program. So this is a signalling program upgrade for the metro there. And what we were doing before the signalling had been installed was looking at how the signalling would run, and particularly looking at how the metro would be operating, particularly under delayed conditions. And this is some work in India. So here, what we're doing here is we've been helping Indian Railways with their ETCS, their European Train Control System rollout program, and actually looking at how they can optimize that design. So again, I think this is 170 kilometers of railway. And what we're doing is we're modeling this and looking at what might happen over time as they upgrade different parts of the line and the benefits that might come and when they might come, and where the low-hanging fruit, the benefit is in the first instance. Then back here in the UK, we've been doing work on the West Coast Main Line. I previously showed you the East Coast Main Line, but this work's really different and really interesting in terms of what we're doing. So instead, as well as that simulation, what we're doing is collecting real-time data. So we've now moved this so that we can look at real-time train movements and then jump into simulation as perhaps things start to go off a timetable. So we can then provide real-time decision support through this mechanism. So this video shows live train movements. So we can start, as I say, to see what's happening in the real live railway. And this is a very, very large section of railway, about 500 kilometre section of railways. And we're right down into the detail of particular parts of the line. And we can see where the trains are instantaneously. We can record those live train movements. And obviously we can replay them if there's been an incident through the simulation. And then we can assess what might happen if we'd have made a different decision, and we can then start to build that into a real-time support decision. And then the final video I want to show you in this project is the work we're doing with HS2, the high-speed line. So here, the line is just beginning to be built, but what we're doing here is we're modelling the operational resilience of the network before it comes into operation. So when the railway line opens in a few years' time, we'll be able to have all these simulations. We'll be able to understand what the effects should be and how we should operate them under delayed conditions or when things start to go wrong. So if we're going to jump now to the smart monitoring and autonomous systems theme to look through some of the more electronic techie work that we do in this area. So this is actually work where we've been working with an SME on track in-service track monitoring. So what we have is we have instrumentation that can fit to the bogie of a in-service train, and it can produce very, very detailed results about the track quality. So this is quite powerful. In the UK, we have what's called the new measurement train, the NMT, and that is a very expensive dedicated train that runs around the network perhaps every 12 weeks and measures the infrastructure. It costs many millions of pounds. And what we've been developing and have installed as an output of that research is these small units, not much bigger than perhaps a hard drive size in a box, and they can be fitted to the bogie of an in-service train. There's no moving parts, no things to clean or calibrate, and they can produce results that are very, very close to the very expensive measurement train. So you can see that on the left here with this graph. The green graph is the measurement train and the black graph is the processed unit. So for our unit. So here what we've been doing is working hand in hand with an SME to help establish, develop, validate, prove this technology, and then supporting that with the SME into the international marketplace. And actually here's another type of project. This one actually is within the university at the moment, and this is a small ride quality unit. And here we've been working with Hitachi on putting this on the high-speed trains that go up and down the route to the Channel Tunnel. And this is producing ride quality results, and it's a few £100, so a very cheap unit. And this is then providing measurements against the European standard for ride quality. Just looking at decarbonisation. So in the decarbonisation, we're back to simulation here, and we're back actually to Singapore. So this is the, oh no, I don't think we are actually. We're in Guangzhou now. This is a line in Guangzhou where we've been looking at energy saving, and we've been working with Guangzhou Metro to look at how we can change the automatic train operation or the driving strategies for real-time drivers to save energy. And the work we've done is saving in operation about 7% of the energy used on the Guangzhou Metro. So a real significant saving. They're using many kilowatt hours of energy each year. So within this work, we were able to optimize the trajectory of the trains, look at the overall savings, model the whole network. We've also been working on retractioning. And this is one of our flagship projects where we've been working with an industrial partner under the UKRRIN banner, under that technology transfer banner, to create the UK's first hydrogen train. It is actually really interesting because it's a converted train. In fact, we think it's the world's first train that was once powered by different means, but is now powered by hydrogen. And to give you an idea of how these relationships work really well for us, we were able to create this train in a year from initial concept through to it being approved to run on a test track. And then it took us another year to get it approved to run on the main line. And you can see it here running on the main line through the English countryside. And then just finally, a few words about education and skills. So education and skills is very important to the rail industry. It always has been, but it becomes increasingly important as we move through the take-up of these technologies that I've been talking about today, as we move through into digitization and the transformation of the railway, bringing on new signalling systems, making better use of decision support, monitoring and automation, all the things that we're focusing on here at Birmingham. So we have a program that we've been operating for many years, actually, around railway systems engineering. So this is really for managers, highly qualified engineers already in their particular disciplines. But we have undergraduate degrees, so this is to develop those staff, and then an MSc program, a Masters in Science program, which is a bit like a technical MBA. And it's structured in such a way that students can come here to Birmingham for a year to study, or they can fly in and out. So we've had students from Southeast Asia, we have students from Australia that fly for a few weeks to the UK each year and finish their MSc over 2 or 3 years. We've also been running a program in Singapore for a large number of students where we've actually flown to Singapore to deliver to the students. And we've been working for 5 years with Singapore and now have 250 students graduated through that program. And we're just starting new programs of that kind in Dubai and Hong Kong, and beginning to talk about doing similar things in other interesting countries around the world, like Egypt and Brazil, where there is an uptake of new railway systems. All our programs are accredited by various institutions, remembering that we're a top 100 university in the world, so they come with that quality stamp as well in their own right. And then, as I mentioned at the beginning, this year we've taken on what's called the National College for Advanced Transportation Infrastructure. It's slightly confusing because it's actually 2 locations in the UK, a campus here in Birmingham, actually the other side of the city to where the university is, and a campus in Doncaster. As you can see, they're large, significant infrastructure buildings to help with education. And these are focusing on that, what we call level 2 to level 5, that vocational education. And so that sits very nicely with the established university education program, so that we can provide education to students at any level, whether that's more academic, university-based education, or whether that's more vocational education. So it's been lovely to speak to you today. If you would like to reach out and ask me questions and be introduced to other members in my team, please feel free to do so. We're very, very keen to collaborate with all sorts of different partners around the world. I'd be really look forward to hearing from you. You can see my email address here on the screen, as well as my Twitter identifier if you are into those sorts of things. Thank you very, very much. I look forward to hearing from you.